Bismillahirrahmanirrahim. Assalamu alaikum. I welcome you all to the fifth lecture for the course of Computer Networks and Internet Working. Today is our fifth lecture. My name is Engineer Jaffar Ali and I am instructor for this course. So let's start with a recapitulation of the previous lecture. So in the previous lecture, we have discussed about transport layer protocols. That what are transport layer, what protocols does this transfer layer use, and we have done the introduction section. And in services, we saw that there was three major services that is provided by transport layer protocols. The first one was UDP that we already discussed in the previous class, and the other two ones was TCP and SCTP that we will be learning in today's class. We saw that UDP is actually connectionless protocol, and there is no fixed or dedicated path from the transmitter towards the receiver, and each packet has to find its own route towards its destination. So it is not that much of in terms of reliability is it not recommended to use UDP. But if you want to use something that needs quick delivery and fast linking, so that is where you can use UDP actually. Now coming towards TCP, TCP is a connection-oriented protocol, and you know that this is if it is connection-oriented, it might be reliable. It is more reliable as compared to UDP. So to achieve this goal, TCP uses checksum for error detection and for retransmission of lost packets, and other acknowledgements and timers are also used in TCP to make this service to make the process more reliable, more efficient, and this service is normally used where you do not want your packet to be lost. So this is this format for the TCP segment. You can see that the header is now become 20 to 60 bytes. The header is size of the header is become more large because I've told you that the UDP is much faster, and one of the reasons for that is the size of the header as well. UDP uses 8 bytes of header while TCP provides you 20 to 60 bytes of header. Means there is a lot of information that is hidden within the header file. So you can see that in the header file there are source port address, destination port address. Now there is another thing that are involved other than the UDP, that is sequence number, acknowledgement number, length of the bits, header length, and received bits, reserved bits. There are some flags as well. You can see there is checksum provided to you. You are also provided by the window size. There is an urgent pointer as well. If you need some urgent to tell the ask the or to tell the receiving end this packet is has to be processed urgently, so he has an urgent pointer as well. And there are several other options that you can this thing is basically 20 bytes. This thing is of 20 bytes, this information, and the remaining information is up to 40 bytes. You can add up to 40 bytes of other information in your TCP segment. So that is why it takes much time to be delivered as compared to UDP. UDP is very light as compared to TCP, and now you know the reason that it is because of the size of the header. It is almost more than 2 to 3 times. So it will also take more time as compared to UDP. We will discuss all these things one by one. And there are some silent features of this TCP. It provides you process to process communication, stream delivery service, numbering system. You see that this is numbering system, sequence number, acknowledgement number. So it provides you a numbering system. There is another service that full duplex communication. You can use multiplexing, demultiplexing. It is connection oriented service, and it is most reliable service as compared to a UDP. Now, what is stream delivery service? Stream delivery service, you see that TCP allows you to send your data into a stream as a stream of bytes. So the receiver will also have to be synchronized to obtain that receive. You can see that it is continuously sending some data. So receiver should be in synchronization with the transmitter. So you see that this is a diagram for sending and receiving buffers. It is very good representation. So if let's say this is moving, this is a buffer, and this is moving in the clockwise direction, and the blue portions are representing the sent packets, and the black are not sent yet, and there are some other packets that you will be embedding. This is your information coming from your process to the application layer protocol of the system, and this is now coming to a transport layer, and transport layer is embedding that into TCP, and TCP is such a thing that it provides and it streams your data into a bytes stream of bytes actually. So at the receiving end, who will how will this thing occur, and the bytes will be coming from this blue will be coming, and this is be received by the time slots. So you do not want your packet to be unsynchronized. Let's say if you are transmitting one data, this is one, and this is, let's say, one. So you want your other data to be received exactly after same time. Do not want any delay. Your packet should not be here, this two should be here and not in the other part, not here. So you have to basically synchronize before actually using the streaming process. So there is a synchronization involved to make sure that there is no delay or irregularities at the receiving end. Now, what is numbering system? Numbering system is very good if you want your system, your network to be more accurate and to be more precise. Let's start with these things. What is sequence number? So sequence number is basically that you know that your packets is your data is divided into small packets and it is received by the receiving end. So how the receiver will know that the packet, the arrangement of the packet is like 1, 2, 3, and so on. If it is not occur, if it is not, maybe the receiving end reassembles the data in 3 to 1, so it will change the shape of the data. So it has to be some, there has to be some number that show the arrangement of the data. Packet has to be allocated a number or assigned a number that will show the sequence number, that packet has to be assigned in such a manner. So this will be your sequence number that will be telling your receiver that this packet has to be aligned in such a format. So this is your first segment number, and this is the thing that you, this is just a theory part. You can learn it by yourself. You have to mention actually the sequence number, that this packet is of sequence 1, this is packet now sequence 2, this packet is sequence 3, so that the receiver may be able to recover that and reassemble that in a proper format, in 1 2 3 format, not 5 9 7 4 or any irregular format. So now coming towards the major part that is provided by the TCP, and that is error control in TCP. So it is achieved use of checksum. You can use acknowledgement. You can use retransmission. See that checksum is the same as it was in UDP, but there was no acknowledgement in the UDP. If the packet has received, destination has received, or the uh, receiver has received the data, so it should be sending some acknowledgement. Now there are two kinds of acknowledgement. One is cumulative acknowledgement and one is selective information. Let's say you have transmitted 4 packets from the transmitter, and receiver has received 4 packets as well. Let's say there is a very good channel, and you are using, let's say, my channel, and I have a very good channel that I have built by my own for different communication purposes. So you are using, let's say, my network, and you are transmitting your 4 bytes uh, to send your receiver actually. So there are two possibilities. I will offer you two services. If you want your selective acknowledgement, so after every receiving of every single packet, 1, 2, 3, 4. So either I can provide you a selective acknowledgement that I have received packet 1. If you receive packet 1, send an acknowledgement. If you receive packet 2, send an acknowledgement. If you received packet 3, send an acknowledgement. So this will be 4 acknowledgements. This is known as selective acknowledgement. And if there is another option that you want to reduce the performance, the overhead control mechanism, to reduce the actually to make the system more efficient, the performance of the system more efficient. So you can use another type of acknowledgement that is known as cumulative. You have sent 4 data, and after receiving of the 4 data, it will send one time acknowledgement instead of 4 acknowledgements. It will wait for all the packets, and after some time it will transmit acknowledgement of 4 packets. Let's say there is a lost packet and you have transmitted 4 packets, and it has received 3 packets. So it may be asked by you that, sir, why will it be sending acknowledgement? Yes, it will be sending acknowledgement because there is a time. It will Receiver will receive, and after some time, if it sees that no packet is coming, it will send the information or the acknowledgement of 3 packets. So the transmitter will know that I have sent 4 packets, okay, and the receiver is sending me acknowledgement of 3 packets, so it means 1 packet is lost. So it will ask the transmitter, it will retransmit that signal, that packet, because in the acknowledgement packet or information is mentioned about the sequence number. So let's say transmitter has sent the cumulative acknowledgement packet, and it consists 1, 2, and 4. So receiver will receive this acknowledgement cumulative information, and he will look that, okay, I have received information acknowledgement of 3 actually packets. So it will know that packet 3 has been lost. So it will retransmit the acknowledgement, that packet, by using the acknowledgement. So retransmission can be done after timeout. It means if the transmitter has sent the data, and after, let's say, 1 hour, it hasn't received the acknowledgement, so it will consider that the packet was not received by the receiver. So it will send the packet again, because the receiver hasn't sent back the acknowledgement. So that is the first time. And another possibility of that is that your packet is basically, so this is your error control continued. TCP implementations today does not discard out of order data. If you have received your segments in the irregular manner, let's say I have received 1, 2, and let's say I have received 4 to 1, and 3 is missing, and receiver does not know that. Receiver does not know that 3 is missing. He considers that this was the packet which was transmitted by the transmitter. So he will not know that there is a loss on the packet. But it will, if the transmitter will send an information and the data 3, so it will keep this information in a buffer. It will not discard this. It will keep it unless and until it is totally unused, or for a much time. So this receiver will be holding the data in a buffer that is a temporary memory, and flag them as a out of order segment, because this is out of order segments. This is not in order, and some packet has been lost as well. So it will save it in a flag in a temporary buffer, and will flag them as out of order. And if, let's say, the missing packet is arrived, so it will take that now again, and it will transmit it for the further use. So until and unless this 3 has arrived, this will be in this memory, temporary memory. And after some time, if, let's say, after 2 days, if the packet hasn't arrived yet, that this thing will be discarded, but it will be stored in some time, till some time. It will not be discarded immediately. So TCP also provides you a congestion control as well, using different policy, slow start, congestion avoidance, fast recovery, and we will discuss that in class, inshallah, that what is these things. Congestion, you know that congestion is when your system gets or your network gets overloaded because of the delay in the queues. So your system might be affected, the performance of the system might get disturbed. So coming toward the stream control transmission protocol, SCTP, I have told you that SCTP is basically a combination of some features of UDP and TCP. It is not the it's not possible to combine the best features actually. So it is also possible to combine some one of the best and one of the average features. So this you can see that this provides process to process, multiple streaming, multi-homing. I will discuss that one by one. Full duplex communication, connection oriented service. It is most reliable service as compared to UDP. So this is the SCTP packet format. You can see there are general header of 12 bytes. You see that in UDP the packet header was 8 bytes. In TCP there was 20 bytes header. So this is in between these two. You can see that how it is uh, combined the some of the good features and average features. So it has combined and come up with the 12 bytes header, and this is the header. It stores source port address, destination port address, a verification tag, and checksum. These are used for acknowledgement and error control mechanism. So you can see that what is multiple streaming. So if you are using same process and you are transmitting multiple stream of data, audio, let's say video, so your data you can achieve this by using SCTP. SCTP provide you multiple streaming, but the channels would be different. It should be kept in mind that you will be using different channels for different streams. You cannot tune. Let's just take an example. If you are watching a TV, watching TV, and you want to see a cricket match, so it is not possible that a cricket match along with a cooking show. Let's say your moms want to see a cooking show, want let's say your mom want to see a cooking show on the TV. So it is not possible that both of these streams occur at the same time on the same channel. It may be possible that you have to divide the channel. So you basically divide the channel. There are some technologies emerging that basically divides the channel. Half of the channel is allocated for the cricket, and half of the channel for is allocated for, let's say, cooking show. So you can easily watch your cricket show at that channel. At that channel, you have divided the channel, and your mom can watch the cooking show as well on the same TV. But the channel is now divided. If it is not divided, it would be possible that you will see that the Virat Kohli is now cooking the show, is now cooking some steak. So this is not a good mechanism for streaming. You have to divide the channel. You can see that we have divided into different chunks. So the stream will be different. Multi-homing is another process that if you want your device to send your information or the request or the packet towards the server or the receiver through different parts, through different mediums or through different levels of hierarchy. So you can use multi-homing. So it is a good thing. Your packet will be maybe this packet get lost in some kind of this router. This router does not allow your packet, and it creates a delay over here. So it might be possible that your packet has received by the server using this path. So if you are using only one path, it is most probable that you face a delay or you face a loss of packet. So if you are using multiple path, that is multiple homing, so it is possible that you receive the data from this side, maybe in the reverse path. Let's say in the reverse path, this router has been down due to some power failure, so you will be receiving data from this path. So there are multiple options in multi-homing concept. In the coming class, we will look at different protocols, several other protocols that are about ARP and RARP. So be prepared for that as well. I will be uploading that video in a very short time. After you see this video, please do watch the other video that is coming after it. So that's all for today now. I think that this was enough for today's class, and I look forward to your good questions. I will be happy to answering your some technical and conceptual questions. Do write it with yourself, and inshallah I'll see you in the class. Come up with the good questions. That's all for today. Thank you. Allah Hafiz.